name is T. Sing Yi from the Financial Mathematics Year 3. Today I would like to explain about my assignment, which the title is the application of the stochastic differential equation. First of all, the introduction. In this assignment, we will investigate the relationship between the prey and predator. As the number of the predator increase will lead to the decreasing in the population of the prey. And furthermore, the addition of the environmental noise will lead to some extinction of the population species. And this environmental noise is introduced by the Werner process, in particular Brownian motion process as well. For the problem statement, many of the researchers wish to recognize the best model of the species interaction, and the stochastic formula will be needed in this assignment. So for the methodology part, they have three assumptions here, and the x1 is represent the prey and the x2 is represent the predator. For the first one, prey species increase exponentially in the absence of the predator, and we will get this formula, and the ART represent the birth rate of the prey. For the second assumption, the predator die exponentially in the absence of the prey species, and the CRT represent the death rate of the predator. And the last assumption is when both of the population of the species is present, and we will get this formula. And from three of these assumptions, it can form two formula for the prey and the predator. And the BRT here is represent the death rate of the prey, while the DRT here is represent the birth rate of the predator. And the parameter of the A, B, C, DRT is a non-negative constant. So as I said just now, an addition of the environmental noises will lead to some extinction of a population species. And we will take the local Volterra model, which in this formula, where the PI is the intrinsic growth rate of the species I. So they have two types of the noise, which the type 1 and type 2, where the type 1 noise is the error is independent of the state, and the type 2 noise is the error is dependent of the state. And we will get the formula separately, which is shown in here. And derivative of WT is represent the white noise, WT is the Brownian motion, and the beta I and the sigma ij is represent the intensity of the noise. So we can form an stochastic differential equation for the type 1 noise and the type 2 noise from the original Volterra model as I shown just now, and we will get this formula for the type 1 noise and this formula for type 2 noise. And for my experimental result, we will get 5 graphs, which the first graph show that the population is remain unchanged, which means that there is no increasing or the decreasing in the population over the time. For the second graph, the red line is represent the population of the predator, and the blue line is represent the population of the prey. So here we see that the relationship of the prey-predator is like an oscillation dynamic cycle, which they have a strong relation with each other. And the third graph, this graph is represent the addition of the environmental noise, and we can see that the red line, which the population of the predator is 4 to 0. And the fourth graph is a closed circle, represent the total amount of the energy conserved in each cycle. So as the population of the rabbit is 4 and yet recover, but the population of the predator, which the forces is remain sizable at the lowest of the rabbit density. So the last graph, there is no energy conserved in the addition of the environmental noise, but we can see that the population of the predator is face an extinction problem, which the population is forced to 0. So in my conclusion, the addition of the Brownian motion noise it prevented the outburst of the population in finite time, and it will lead the population species to face some extinction problem. Thank you.